Do you watch those videos again?
Yeah, like sometimes when I get stuck, I just go back.
All right. I mean, this is gonna be pretty chill because all right.
Yeah,
For
my
this, you
teacher's
need
not.
the special triangle. Do you know how to draw the special triangles?
Mhm. The 45, 45. Oh,
Yeah,
but yo, I'm also confused on that because my teacher says like you have to divide it by 2, but I don't know when I do that.
divided by 2. What's the sine of pi over 4? What does your teacher say sine of pi over 4 is?
Uh, Sine pi over 4.
Or sine 45. What does he say it is?
Oh, he says like 1 over root 2, but then after that you have to like
Yeah,
rationalize
yeah,
it.
because you don't want to have a root in the denominator, so you want to multiply the top and bottom by root 2 over root 2, because you're just basically multiplying by 1. So sine pi over 4 is root 2 over 2.
But like I'm confused. Is my special triangle like 1 root 2, or is it 1 over 2 1 over 2 root 2
No,
over
no, when
2?
you're building it, it's 1, 1, root 2. For the 45, 45,
Mhm.
it's 1, 1, root 2.
But then when do I divide it by 2 and rationalize and all that?
You rationalize it when there's a root 2 in the denominator. Like for example, this one, tan 45 is going to be 1, right? There's no need to rationalize anything. 1 over 1 equals
Yeah.
1. But both sine and cosine, you're going to have to rationalize it because there's now a root in the denominator. So to
Mm,
rationalize it, just multiply it by itself on the top and the bottom, then you get root 2 over 2.
but I only rationalize after I figure
Yeah,
it out.
after you figure out the ratio. And if there's a root in the denominator, if it's in the numerator, don't worry about it. You don't have to do anything.
Okay.
Okay, let's look at this. Sine of 2 pi over 3, which quadrant?
First.
First quadrant, right? So what's the related acute angle? Oh, it's not first, it's
Oh,
second quadrant.
second.
Yeah. What's the related acute angle?
60.
Uh,
30.
no, pi over 3, right? Tell it to me in terms of radians. Pi over 3,
Oh, pi.
60, 60. So sine 2 pi over 3 is the exact same, and you can just find that out by doing pi minus 2 pi over 3. 180 minus, I think this is 120. So you get 3 pi over 3 minus 2 pi over 3, pi over 3, you see, in radians.
Okay.
So sine of 2 pi over 3 is the exact same thing as sine of pi over 3 and sits in quadrant 2. Cast rule tells us this is positive. Okay.
Sine pi over 3. No, but I think this one's different. You're not supposed to find that. I think you're supposed to find like the.
No, this is the only way to do these. Step 1, you have to rewrite it in terms of the related acute angle, okay? And in the cast rule, so it's this. And then we know sine of pi over 3 is root 3 over 2, which is the final answer for this question.
Okay, okay.
And this comes from the special triangle, okay? Memorize that if you can. Let's keep going. B, 10, 11 pi over 6, which quadrant?
Last one.
Yeah,
4.
and what's the related acute angle?
30.
Uh,
Pi over 6.
pi over 6, exactly. So tan of 11 pi over 6 is the exact same thing as tan of pi over 6, except in quadrant 4, tan is negative.
Mm-hmm.
Now, what is tan of 30? I think it's root 3, negative root 3. Or I might be, no, it's actually 1 over root 3, right? Tan of 30. Yeah, it's 1 over 2 over root 3 over 2. It's 1 over root 3.
Yeah, it's just 1 over root 3, but
Now you have
it's.
to rationalize it, right? Yeah, so multiply it by root 3 over root 3. So you get negative root 3 all over 3.
Mm-hmm.
Cool?
Yeah.
The last one, cosine, or not cosine, that's cosecant. That's 1 over sine, the reciprocal of sine. So cosecant of 5 pi over 6, we know this is in quadrant 2, right?
Mm-hmm.
And the related acute angle is simply pi over 6.
Yeah.
And we know sine of pi over 6, sine of 30 is 1 over 2. That means cosine of pi over 6 is, again, in quadrant 2, this is positive, so we don't have to worry about the sign. It's 2. 2 over 1 or 2. Just flip the ratio of sine.
And then it's
That's
going
it.
to be
Just 2. Just 2.
1 divided by 0.5.
Yeah, which is 2.
Okay.
Yeah, 1 over 1 over 2 is 2.
Mm-hmm.
Or you can just flip the sign. Sine pi over 6 is 1 over 2. That means cosecant of pi over 6 is 2 over 1.
Yo, I don't know if this is a dumb question, but why is sine with cosecant? Like,
I
I
don't know. That's just a naming convention they came up
thought it
with.
would be sine and
Yeah.
secant.
So sine goes with cosecant and cosine goes with secant.
That's so dumb.
And tan is pretty straightforward. It's cotangent. Yeah, sine goes with cosec. I don't know. The Greeks, they were having some good rum or something. I don't know.
Yeah, they're tricky.
Yeah. So that's that. Do you understand these?
Yeah, I think I get those. I was just confused about the steps. Like,
Okay, let's do one more. Okay, step number 1 is to rewrite this in terms of its equivalent related acute angle. Yeah, 5 pi over 3. This is in quadrant 4. The related acute angle is simply pi over 3.
pi over 3, yeah.
And we know secant in quadrant 4 is positive. So step 1, rewrite it in terms of its related acute angle. Step 2, use the CAS rule to see if it's positive or negative. So this is positive, and this is cosine 60. I know cosine 60 is 1 over 2. That means secant of 60 is just 2.
Okay, so related acute angle, cast rule, and then
Special triangles, special triangle. This comes from the special. That's step 3, special triangle to evaluate the ratio. And sometimes you have to flip it like in this case.
Okay, like my teacher said we're allowed to have the unit circle.
Okay, that's even better then, yeah.
Yeah, I can just look at it and I look at like the coordinate.
Yeah. But I think that this is pretty simple as well though, right? I mean, it's
But I
just
don't know
2
why
steps.
my head's like tripping about the special triangle for some reason.
All right, what's the next question?
Let's do number 6.
Okay, so we just have to do, let's just do 2 of them, okay?
Yeah,
No, we don't have to do all of them. So they're asking us to determine the value of cosine. So in this case, okay, for any ratio, there's going to be 2 different angles. Because if you think about it, cosine is positive in quadrant 1 and 4, but see cosine is negative in 2 and 3. And this is a negative ratio, and we're only interested in cosine. So there's going to be 2 different answers to this, 2 different angles. One of them is going to be in quadrant 2, okay, this angle, and the other one is going to be in quadrant 3, this angle. To do this, step 1, you need to find the related acute angle. To find the related acute angle, you take the cos inverse of the absolute value. You don't care about the negative sign, because the related acute angle is always positive.
Cos inverse of the related acute angle.
Oh, of the ratio, because this is the ratio, right? The absolute value of the ratio. I think that's 30, but I'm gonna double check. It's 60. So yeah, there we go. Sine of 30 is 1 over 2 cosine of 60. So with this one, our related acute angle is pi over 3, 60 degrees. So we know this is pi over 3. Again, the related acute angle always goes from the horizontal, right? And we know this is pi over 3. Now think about it. If this is pi over 3, what is this angle?
That's going to be 2 pi over 3.
There you go. So one of the answers is 2 pi over 3. And again, if this is pi over 3 just from 180, what is this entire thing?
4 pi over 3.
Exactly. And there you go. There's 2 answers, 4 pi over 3.
Like is it because there's 2 versions where it's negative?
Yeah, there's cosine is negative in 2 quadrants. That's why.
Okay. I think I got that.
Cool.
Yeah, and do you think like I'm always allowed to have a calculator? Because like, what if I can't do the?
You don't need a calculator. You don't need a calculator. You just need a special triangle or the unit circle. To do anything we've done today, you don't need a calculator. You are going to need a calculator when they throw like these. These numbers are going to give you wacky decimals, but not for these. These are all special triangle angles.
Yeah, like you know when you said the absolute value thing, how would you do that without calculator?
Oh, absolute values, just ignore this negative sign.
Well, never mind.
Just ignore the negative sign.
You did cos inverse though.
Yeah, cos inverse, that comes from the unit circle, right? So you want to see where it's 1 over 2, where the x value is 1 over 2. And you'll see that it's going to be at 60 degrees or pi over 3 on the x value is 1 over 2. Look at it on your unit circle. What is the x value in quadrant 1, 1 over 2? At 60 degrees.
Okay, so then I know the
related acute angle is pi over 3, and exactly. And then quadrant 2, it becomes pi minus pi over 3 for the angle. This is for quadrant 2, and quadrant 3 it becomes pi plus pi over 3. So that's how we got 2 pi over 3 and 4 pi over 3.
Oh, because we need another related acute angle like that.
Oh, no, the related acute angle is going to be the same, but we need another principal angle. One in quadrant 2 given by this, other in quadrant 3 given by this.
Okay, yeah. I think I get it now.
Let's look at C. And again, tell me, what's the cos inverse of root 2 over 2?
The x value is root 2 over 2 at pi over 4.
Exactly. So our related acute angle, I'm going to call that alpha so you don't get confused. Actually, that's what I should have done before as well. Alpha is a related acute angle, okay?
Okay.
Alpha is pi over 4. And we know cosine is negative in quadrant 2, right? And this is the same thing as the question that we just did, quadrant 3. So the two answers for theta, theta 1 is going to be pi minus pi over 4, 3 pi over 4 in quadrant 2, and then pi plus pi over 4, 5 pi over 4 in quadrant 3. And there you go. It has two different answers.
Okay, yeah. Yeah, that's actually easier than I thought.
It's pretty simple. And the only time you're going to need a calculator is when they give you something like this, because these are not going to be nice special triangle ratios.
Yeah, let's try this.
Let's try this. All right, sure. The terminal arm of an angle. So let's see where -7 and 8 is. Okay, again, you don't have to be precise with this. The y value is positive, the x value is negative. -7 and 8 is here, okay? You don't have to graph it perfectly like there. So there you go, that's our terminal arm. The question's asking us to find this angle in radians. Okay? Now what you need to do is you need to turn this into a right angle triangle. So I'm going to turn this into a right angle triangle like that. The height of this triangle is 8 units, right? And the length of this triangle, or the base, is 7 units. And now we're going to find alpha, a related acute angle. How do we find alpha?
Tangent?
Yeah, tangent inverse of, so tan inverse of 8 over 7. That gives us 0.85. So alpha is 0.85. But we're not looking for alpha. We're looking for theta, right? The principal angle.
And that whole thing is going to be pi.
Pi, exactly. So that means our theta is going to be pi minus alpha, or 3.14159, whatever it is, minus 0.85. The value of pi is just 3.14, right? There's a button on calculator called pi on most calculators. That gives me to 2 decimal places, which is what hundredths means, right? 2 decimal places, 2.29.
Wow. Okay, that makes so much more sense.
Right. We can do one more. 3 and 11 is going to be all the way up here. So on the x, it's 3 units. The height is 11 units, right?
Yeah.
I mean, in this case, alpha will be theta because it's in quadrant 1. And then you just do tan inverse of 11 over 3 and you'll get the answer because alpha is theta. Theta is acute in quadrant 1.
So we're just finding the related acute here?
No, we're finding the related acute, but in quadrant 1, related acute angle is the principal angle.
Yeah, so it's the one that starts at the origin.
Yeah, exactly. Yeah. So in this case, both the related acute angle and the principal angle in radians anyways is 1.30.
And it would never be like you know how we did 8 over 7? It would now be like 8 over -7, right?
No. Acute angle is always positive. The ratio has to be positive for the related acute angle. Okay?
Even though it's -7?
Yeah, even though it's -7. So it works like this. Here, alpha is theta. Okay? Here, again, theta is the principal angle. Here, theta is pi minus alpha, or alpha is a related acute angle. In quadrant 3, theta is pi plus alpha. And in quadrant 4, this is alpha, theta is 2 pi minus alpha. And alpha is always going to be, whatever the ratio is, it's going to be the absolute value of this ratio. Don't put negative numbers here.
Whenever it's 10?
No, it doesn't matter what it is. For alpha, whenever we're trying to find alpha, right? It's
Yeah.
always gonna be the absolute value of the ratio because alpha means acute angle.
Mhm.
That means the ratio has to be positive.
Yeah. Okay. I feel.
How do you feel about that? You can
No,
do one more here. Let's do this one. -4, -2. Which quadrant is this in?
it's gonna be in quadrant 3.
Right. So again, we're gonna draw a triangle, right? Let's say this point is -4, -3. So the height of this triangle is 2 units. The length of this triangle is 4 units. See that?
Mhm. Yeah.
And this is gonna be our alpha, the related acute angle. So to find that, we just do tan inverse of 2/4, right? Or -2/-4, or absolute value of that. Just the positive, we're only interested in positive numbers. And that gives us 0.46 as a related acute angle. How do we find theta?
Theta, you're gonna do pi plus alpha.
Right, exactly. And pi plus alpha, so 3.14. Again, pi button is there on the calculator if you want to use it as well. So that is 3.60 for this one.
Could we do 1 from 8? Try 1 from 8.
Give me 1 second. My tip pen just fell.
Yeah, don't worry. Take it down.
Stupid tablet pen. Are we back in the game? All right, we're back in the game. Which one did you say?
Number 8. If we just did 7.
All right. This is the same thing we've been doing pretty much
Was it
all
10?
day. Yeah, extremely sim. -pi/6. Which quadrant is that in?
Quadrant 4.
4, right? What's the related acute angle?
Pi over 6.
Exactly. So sine of and again, sine is negative in this quadrant, right? Step
Mhm.
1, find the related acute angle, pi/6. Step 2, use the cast rule. Sine is negative here. So sine of -pi/6 is the exact same thing as negative sine of pi/6. Thus the
Oh,
acute
why not
angle.
put the negative in front of the sign though?
Oh, because using the cast rule, sine lies in quadrant 4. Sine is negative in quadrant 4. Only cosine and secant is positive.
But you're telling me that there's never going to be a negative in front of the pi over 6?
No, oh well, it is like here. Look at this.
No, I'm saying, yeah, I know it's there, but I mean, like when you write your answer.
No, never. No, not in when you're writing it in terms of the related acute angle.
Ew. Okay. That was good. Can we do 13? Because I remember I tripped out on
13 is this what I think it is? Because I don't want to do it if that's what I think it is.
that. I don't
No,
even
it's
know.
not. No, this is fine. This is fine. I'm thinking of something else.
Oh, is there something like deadly in this?
Yeah, there's something that takes like 10, 20 minutes to do, and I hate that question. I'll tell you if it pops up. I think we already moved from that, so it's good for us. Anyways, okay, so this one, look at cos is negative, right?
Yeah.
In which quadrant is cos negative?
In the second and third.
Exactly. So the answer to part A is quadrant 2 and quadrant 3.
Mhm.
Part B, determine all the possible trig ratios for theta.
Yeah, this is where I did not know what was going on.
All right, so for this one, we have to do it 2 different ways, okay? Because we know cosine could be in quadrant 2, yeah?
Yeah.
Or it could also be in quadrant 3. Step 1, using SOHCAHTOA, cos is the adjacent over the hypotenuse, right?
Yeah.
And then this ratio is equals to 5/13. Again, you don't have to care about the negative sign. That just means it's in quadrant 2, quadrant 3. Okay.
And how do I know which angle we're talking about here?
We don't know the angle just yet, but we do know it lies in quadrant 2, one of them, and the other one lies in quadrant 3. Step 1, you want to build a triangle. Build a right angle triangle in those 2 quadrants. Cosine is adjacent over hypotenuse, yeah?
Yeah.
Which is 5/13. So that means both of these triangles, let's say our alpha is here, right? Alpha is here. Our adjacent is 5 units. So this guy right here is 5 units, and the hypotenuse is 13 units.
Wait, yo, did you just assume that that's alpha? Like, cause the
No,
related.
that's the related key. I didn't assume it is what it is. That's alpha. I'm
No,
not,
I mean like the cos thing. It's talking about the alpha, right?
no, cos is talking about theta. Cos, this is theta. Theta is this one, and the other theta is here. The principal, theta represents the principal angle, okay? But to find the principal angle, first we need to find alpha, and then we're going to do pi minus pi plus.
Okay, I'm still tripping, but yeah, continue.
So this is our triangle, okay? 5/13, yeah?
Mm.
So that means we can use, again, we're trying to find alpha, right? So alpha is equals to cos inverse, yeah?
5 over 13.
5 over 13, exactly, 5 over 13. But remember, that's just alpha.
Mhm.
So cos inverse of 5 divided by 13. That is 1.18. Okay?
Mhm.
So that means our principal angle, you see this one right here in quadrant 2? Yeah?
Yeah.
Theta is going to be pi minus alpha. And our principal angle in quadrant 3 is going to be pi plus alpha.
Mhm.
So it's going to be pi minus 1.18. For the first one, it's 1.96. For the other one, it's pi plus 1.18. It's going to be 4.32.
Yo, is this this is a trigonomic ratio?
Yeah, it is. Well, we just use the inverse cosine to find what alpha is. We just did this question. I thought you understood it like somewhere here. Like
No,
here,
trust is different.
it looks different, but it's the same. Once you have the triangles, right? We're just finding alpha by doing cos inverse or whatever the ratio is. And then we're trying to find the primary by doing pi minus, pi plus.
Hold on. Trying to pull up the solution because I swear the solution is weird. It was not like a normal. Yeah. So the solution is like it's like sine 12 over 13
No,
over.
what's the answer to C? I found the answer to C first.
Oh, C, I think you're right. 1.176.
1.96, 1.3. Oh, no, that's the acute angle. Yeah, that's the acute angle, 1.176.
No, 1.176. That's sine theta. And then in the second quadrant, pi minus that is 1.97.
Yeah, see, that's what I found first, okay? I found the angles. And then we can find the ratios. I mean, the ratios are pretty simple. Here, look at this. Again, maybe you're getting confused, but I need to do it. Let me draw two different triangles so you don't trip out here. We know it lies in quadrant 2, yeah?
Yeah.
And we know the adjacent is 5, okay?
Mhm.
And the hypotenuse is 13. Using Pythagoras theorem, you can trust my word, it's 12, the opposite. Because 5, 12, and 13 are Pythagorean triples, just like 3, 4, 5.
Yeah, I know that one.
Okay, and we know this is theta, right? This is theta. Cool?
Mhm.
It wants all the possible trig ratios for theta. Look at this for part B. In quadrant 2, yeah, sine theta is equals to sine alpha, because that's a related acute angle and sine is positive. Cos theta is equals to negative cos alpha.
That's negative.
Yeah, tan theta is equals to negative tan theta. Why is cos and tan negative? Because only sine is positive in quadrant 3.
Mm.
Right? So sine theta equals sine alpha, and we know sine alpha is going to be 12 over 13.
But bro, like you wanna know why I'm confused?
Why?
So you know how it says theta?
Mm-hmm.
Theta is talking about that angle that goes right before the triangle, right?
Yes.
And then our triangle is literally after it. So how does that like relate to the triangle with the 513?
Oh, because theta is the primary ratio, right? The primary angle, yeah?
Mm-hmm.
Look
But
at
then
this.
that ratio is different. Like
No, it's not different. Like, look at this, 120, okay? 120, 60. Okay, yeah?
yeah,
Sine of 120 is the exact same thing as sine of 60.
that's the same thing.
That's the exact same thing. Cos of 120 is the exact same thing as cos of 60, the ratios, except in quadrant 2, cosine is negative. Using the cast rule.
Why is it the same though? What am I trying to like?
Well, because principal angle and related acute angle, they're related. Like they represent the same ratio, except with a different sign. Principal angle is the related acute angle. The ratios anyways, the ratios are the same. The only difference is that it might be positive or negative depending on which quadrant it's in.
Okay.
And then cos of theta is negative cos of alpha, which we already had it, which was minus 5 over 13. And tan theta is negative tan of alpha. So that's going to be negative 12 over 5. This is assuming it's in quadrant 2. But we know this could also be in quadrant 3 because that's where cosine is negative as well. So now let's build a triangle in quadrant 3. Our alpha is here, okay? And this is our theta. This big thing is our theta. And we know in this triangle, the adjacent was 5, the hypotenuse was 13, and the opposite was 12. Same thing as this triangle. Now look at
Why
this
is
one.
that whole thing alpha? I mean,
No,
theta.
not the whole thing, only this one. The related acute angle is alpha.
I mean, why is the whole thing theta?
Oh, because that's how it works in quadrant 3. The principal angle is all the way to the terminal arm. In quadrant 2, it's here, right? In quadrant 4, it's here. It's all the way to the terminal arm.
Oh, you just go to the terminal arm.
Yeah, yeah.
Okay.
And for quadrant 3, we're going to get different ratios here. Well, I mean, the ratios are going to be the same. It's only the sign that's going to be different. So sine theta is the exact same thing as negative sine alpha now, because only tan is positive in quadrant 3. That's going to be negative 12 over 13, assuming it's in quadrant 3. Cosine theta, I mean, it's already given in the question, but it's negative cosine of alpha. So minus 5 over 13. And finally, tan is going to be positive. It's going to be 12 over 5 because it's positive in this quadrant.
Oh.
And
Okay.
these for part B, there's 6 answers. There's
Yeah.
3 in quadrant 2, and then there's 3 in quadrant 3.
But like, so the thing is, when they give us that relation that you're talking about, like the primary angle or whatever,
Mhm.
and the alpha, so even though it's saying that's the ratio, it's talking about alpha.
Yeah.
Okay. And when I put sine 60 in my calculator, I get something else than when I do sine 120.
Yeah, because no, you don't. Because you're in the you're in radians. Go back to degrees.
Oh,
If you're gonna
God.
put in degrees, or you can plug in pi over 3 and 2 pi over 3. That should give you a root 3 over 2.
Yeah.
This is 1.17 something, I think.
Sine 120, sine 60. Yeah. Bro, I didn't even know that's why it changed. Let's do number.
This is a very good question, by the way. This question is going to come up on the test. I'm like 90% sure. And there's 2. If you only answer in quadrant 2, you're only going to get half the marks.
Yeah, that's definitely a test question. Okay, can we do number 16 and 17?
Do we have to? I'm
Yeah.
kidding. I'm kidding. 16 looks it's not bad. 16 is not bad. No, there's a question like this. I don't know where I remember it from. And there's like, that one is so long, but this one is chill, I think. So they want the length of AB, okay? AB is the hypotenuse here, right?
Yeah.
So AB is the hypotenuse. And find the sine, cosine, and tangent ratios of D, given that AC is CD equals 8. All right, here's the thing. Step 1, okay, we're gonna cheat a little bit. By cheat, I mean, do you know the properties of an isosceles triangle?
Bro, I forget what isosceles even means.
Isosceles means this side is equal to this side.
Okay.
If in an isosceles triangle, if there's a right triangle here, like a right angle here, you see? That means the other 2 angles are 45 degrees each.
Oh, you're saying the things on the right.
Yeah, so up here is pi over 4. And down here is pi over 4. And that's a property of an isosceles right angle triangle. Both the angles are 45 degrees each, or pi over 4 radians.
Okay. I have to remember that.
All right, and from here it's very simple. So let's look at finding AB first. Okay, let me redraw this so it doesn't get cluttered. So this is 90 degrees, this is 8 centimeters. This is pi over 6, right? We want the hypotenuse, we have the opposite. Which ratio do we use?
10?
No. O over H. So
Wait,
10 is OR, right? OR. We don't have adjacent. We're not looking for adjacent. We're looking for hypotenuse.
what do we even have though?
We have opposite, 8. See, 8, this one.
Well, opposite over hypotenuse.
Yeah, so that's sine, right?
You
want to look at what you need, what you have. OH is sine. So we can kill this question in 10 seconds. Sine pi over 6 is equals to opposite 8 over the side length AB. Multiply both sides by AB to bring it up in the numerator. This is going to cancel out. And then you have AB sine pi over 6. I think that's, what is that? 1 over 2. Sine pi over 6. Sine 30 is 1 over 2, pretty sure.
Is this like the sine law?
No, this is not sine law. This is SOHCAHTOA. This is
There's no
literally
sine
just
law?
sine. Okay, here. Again, let me set this up. Sine theta, yeah, is equals to opposite over hypotenuse, right?
Oh yeah, so you don't even have to do it.
Yeah, so opposite is here. Hypotenuse is what we're looking for. So that means hypotenuse is opposite over sine theta.
You can just change it around.
Yeah, you can just change it around like this. Are you what here? Let me show you the steps. You're multiplying both sides by h. Okay, this cancels out. Then you're left with h sine theta over equals O, and then you want to divide both sides by sine theta. You see, you literally end up replacing these two.
Yeah.
It's a
Okay.
neat little math trick. Okay, so hypotenuse, which is our AB, that is equals to O, which is 8 opposite side, divided by sine of pi over 6. And that should give you 16.
Damn. Okay. I was actually tripping on this unit for no reason.
And that's easy, super easy. And then to find the sine, cosine, and tan ratios of angle D, sine of, we need the hypotenuse though. So we know that's 45. This is 8, right? 8, 8. So this is going to be the square root of 128 using Pythagoras theorem, right?
And then
And
you
we
find
know sine D is 45 degrees, right? Actually, we didn't even need that because they just want the ratios. So sine D is equals to opposite over hypotenuse. Cosine D is equals to adjacent over hypotenuse. And tangent of D is equals to opposite over adjacent. 8 over 8 is a 1.
But yo, there's no like negative or positive in this.
No,
There's
because
no
they
problem.
represent the side lengths of a triangle.
Yeah. So we just consider there's no like quadrants.
No, don't worry about quadrants. They're all acute angles anyways, but more importantly, they represent side lengths of a triangle, which is usually almost always positive. It's a
Okay.
length, right? Length cannot really be negative. Or distance, it's a measurement of distance. It's not a vector quantity or whatever.
Okay. Let's do 17. Then I kind of want to do like a little bit of like the translations of the new graphs.
Okay, we'll just do 2 of these, okay?
Yeah.
Then referring, explain why each equality is true. Draw a triangle of both angles. All right, so is x acute? Yes, it is. So let's draw A, okay, A first. So we have this, right? Yeah. This is x. Now, pi minus x, what does that mean?
So pi is the whole 180 degrees.
Yeah.
And subtract that one angle that we have.
Right. So this is going to be x, right? That's the acute angle. And our principal angle, this one is going to be pi minus x.
And then you're just drawing your related acute on the other side.
Yeah, because they're equal. We're trying to show that both of these triangles have the same measurements or same ratios.
Oh, that's all?
Yeah, and then sine represents the y value. You see the y value here? I mean, it's the same exact triangle. The y value must be the same thing as here.
And same with the hypotenuse and all that.
Yeah.
Okay.
Okay, this one's pretty simple. You just draw it out in the opposite side. Let's do the transformations.
Okay, so you want me to pull out the homework or do you have some stuff?
No, pull up the homework. I mean, I have the book, I guess. We both have the same thing.
Well, let me get the question. And do you know any like good like scholarships I can apply to that like don't relate to the university?
Like scholarships, you mean?
Yeah, like scholarships or like bursaries, like anything like that.
No, most of them come from the university, I guess. Otherwise, you want to look into like, what are you good at? Coding and maths, right? I don't know about maths. Are you good in coding?
Nah, like me, I'm trying to go into science.
So you could take part in some like competitions that happen, like that'll definitely help you. Or you can try getting a job actually. Like I know like Tim Hortons and stuff, they have a certain amount they'll pay for you if you're in school, if you work for them.
Yeah, but Tim Hortons is like it's like so crazy.
Yeah, but you gotta start somewhere, right? Like,
Yeah, like I just had a job, but like I stopped working there because
because you got fired.
I play soccer. Oh, I did get fired. Yeah. So like I was like, yo, boss, like let me only like work 1 day a week.
Yeah.
But then he's like, we can't do that. Like it's gonna ruin all this stuff. I was like, yeah, whatever. He wanted me to work like 17 hours a week or something.
Wow.
Okay, so page 343, 1, 4, 8, 10, 14.
Uh,
We don't have to do all of them. So.
no, we're not gonna do all of them. So it just says state a bunch of these things. Okay, let's do it for the bottom too, because it's there looks harder. It looks harder. All right. This you're gonna have to memorize this. Okay, memorize this. Don't care about anything else for this transformation stuff. Anyways, you want to memorize this. Any trig function a. So it doesn't matter. It could be sine. It could be cos. It could be tan. Has this form. Okay. K x minus d plus c.
Mhm.
A is the amplitude. Okay. K is nothing special. It's the horizontal stretch or compression factor. Stretch or compression factor. D is the horizontal translation, so that means it goes left or right. And C is the vertical translation, also known as the equation of axis. Vertical translation, and it also represents the equation of axis. I don't know if you remember in quadratics, we also had something called equation of axis or axis of symmetry, right?
Mhm.
Look at this. In quadratics, the axis of symmetry is a line that cuts the graph in half. It's a vertical line, so it's going to be like x equals 2 or something. In trigs, instead of it being a vertical line, it's a horizontal line. Like if you have something like this, right? Let's say this is the halfway mark. That's going to be your equation of axis. It's the c value. Y equals to whatever the c value is. Like let's say it's 1 here, y equals 1.
Yeah, that makes sense. And yo, could we go over like the like what's it called, the reflection and all that, like horizontal,
Now
vertical?
let's do this. Let's graph this. I know it's not asking us for this, but let's just graph D.
Okay.
So step 1, let's identify our AKDC values.
So 5 is A,
Yeah.
and then you factor out the negative. So you're gonna have a 2 as your horizontal stretch, or it's gonna be 1/2.
So K is minus 2 here, okay? K is minus 2. Yeah, it's a horizontal compression by a factor of 2, and it's also a reflection on the y-axis. But don't worry about that just yet. Tell me what the D value is.
Wait, why is it -2 though? How are you
Oh,
gonna
minus,
factor?
minus.
No, how is it like 2 at all? How are you taking that out of the brackets?
No, I'm not taking that out of the bracket. I'm opening another bracket inside of the bracket to see look at the format. K has to be outside the bracket of X.
Yeah, it is. So how is that?
It's
That's
not
in the
outside the bracket. It's being directly multiplied with it. What you want to do here is this. So again, you know the format right now. Actually, I'm going to keep that there just in case you get confused. Look at this. We have 5 cosine, yeah? Negative 2x. See, it's not outside the bracket with the x. It's being directly multiplied with it. So what you need to do is you want to open another bracket inside this bracket. Take the 2 out.
Okay, so it's just not written.
Yeah, and this is going to be pi over 6. There we go. See, pi over 3 is not the d value.
Pi over 3 is not the d value.
No, because you have to take the k out of it. The d value, see, it comes negative. It's negative here. The d value is pi over 6.
Oh, you're dividing everything by 2, -2.
Yes. Pi over 3 over -2 is minus pi over 6.
Okay.
Okay, and the c value is -2.
Mhm.
All right, now let's see what all of these do. A value of 5 means it's a vertical stretch by a factor of 5.
Mhm.
K minus 2 does 2 different things. If K is negative, right? If K is negative, that means it's a reflection on the y-axis.
Reflection on the y.
So like
Yeah.
if it was like this before, like this before, yeah, it's gonna flip-flop. It's gonna be like this now. It's literally put a mirror on the y-axis if K is negative. If A were to be negative, then it's a reflection on the x-axis. It flips upside down. Like this would be this if A is negative.
And what's the mapping rule again? I forgot the mapping rule.
Right, and then d pi over 6 means it goes pi over 6 to the right, yeah?
Yeah.
And c minus 2 means it goes down 2 units. And the mapping rule is this. For any x, y from the parent function, yeah, which is what? For d, it's cosine of x, y equals to cosine of x. You get x over k plus d, ay plus c.
Mhm.
That's why we wrote these 4 magic letters on the side.
Yeah, that's what I was forgetting. Like, okay, so yeah.
And now what? So now we just plug and chug. So again, this is going to be x over minus 2 plus pi over 6, the mapping rule. And then ay, so 5y minus 2, like that.
Wait, isn't it minus 5 or 6?
No, because d value is positive. It came
Oh, yeah.
negative in the bracket, right? And again, the rubric says the general form is k x minus d. See, d is going to be
It's the
positive pi
opposite.
over 6. Yeah, it's the opposite.
P of x. Okay, and then minus 2, and then you just plug in your values.
Yeah, you just plug in your values from the parent function. I don't know how many points your teacher wants. 0 pi over. I'm lazy, so I'm just gonna use the pi over 2. Go by 90. Go by 90.
Okay, 0 pi over 2 pi.
Yeah, and then 2 pi. Cosine of 0 is a 1. Cosine of 90 is a 0. Cosine of pi is -1. Cosine of 270 is 0. Cosine of 2 pi is 1. Okay, remember these points as well. If not, you can just always graph them out, right? Cosine looks like this. See, at 0 it's 1. At 90 it's 0. And then at 180 it's going to be -1. And then at 270 it's going to be 0 again. And then at 2 pi it's going to be 1. Just remember cosine starts at a maximum value. And then you can come up with this table every time. I'll just remember it. Now we're going to plug these as x in there. Okay, plug this as x in here. Plug this as y in here. And we're going to rinse and repeat it 5 different times. The first one's going to be 5 over 6, 3. The next one's a little bit more complicated. Tell me, if I were to plug this as pi over 2 as x in there, what do I get for the whole thing?
Pi over 2 divided by 2.
Yeah,
Like
divided by -2. So pi divided by 2 divided by -2 plus pi divided by 6.
Pi divided by 2 divided by
-2
-2
plus pi divided by 6.
So that gives you -1 over 12 pi.
Yeah, so that's negative pi over 12, yeah? 0 in there as y just is going to give you -2. And then we're going to rinse and repeat pi in there as x. So pi divided by -2 plus pi divided by 6. Again, this is a calculator play. That's minus pi over 3. And -1 in there is going to be -7. 3 pi over 2. Okay, this is going to be annoying. 3 pi divided by 2 divided by -2 plus pi divided by 6. And that is -7 pi over 12. 0 in there is going to be -2. And then finally 2 pi divided by -2 plus pi divided by 6. That's -5 pi over 6. And then 1 in there is going to be 3 again. And there we go.
Okay. And
then,
do I have to understand like the cotangent graph and all that, or do I just have to know?
No, I don't think so. That's stupid. I've never really seen an exam question about cotangent, but you do have to kind of know where it comes from. Like, did you understand this?
Yeah, I understand that.
And you just plot this on a graph. Okay, that part I think I hope you're able to do once you have that.
That I'm good.
All right, so look at this. I just wanted to show you where the secant and the cosecant comes from. Let me draw you a quick graph of sine of x. Okay, sine of x goes through there. At 90, it's 1. Okay. At 180, it's 0. At 3 pi over 2, it's -1. This is sine of x. Okay, y equals sine of x. And then at 2 pi, it's 0. Okay. And then it rinse and repeats. Keeps going like that. There, and then there. On this side as well. But I just want to focus from 0 to 2 pi. Now we're trying to graph y equals to cosecant of x. Okay. Which is the same thing as y equals 1 over sine x. Yeah?
Yeah.
So now look at this. Have you done the rational functions unit?
Yep.
Yes, you have, right? So whatever gives you, whenever the y value is 0 in the denominator, what do you get? You get an asymptote. You get an asymptote, right?
Mhm.
Whenever the y value, again, we're just going to take all of these y values from the sine function, and we're going to do 1 over that to graph this. Okay. Step one, look at this. This is 0. 1 over 0 is nada. So there's an asymptote right there. Big fat asymptote at 0 for cosecant x. Yeah.
Mhm.
Pi, y value here is 0 as well. If you want to plug 0 in there, you're going to get another asymptote there. Same thing at 2 pi, you would get another asymptote there. Cool.
Mhm.
Now look at this. There are some points that don't change for both sine x and cosine x. It's this point right here. The y value of sine x, right? What's the y value for cosine x at this point? 1 over 1 is still 1. So that point doesn't change.
Mhm.
Same thing here. This is minus 1. 1 over minus 1 is still minus 1. That point doesn't change. Okay.
Mhm.
Now we just need to curve this. It's going to look like a u and inverse u. Look at this. Let's say the y value here is 0.5. Okay. The y value there is 0.5. What's 1 over 0.5?
2.
2. So you see that point for cosecant of x is going to jump up there. Same thing here. This is 0.5 on the y for sine of x. For cosecant of x, it's going to jump up there. And now we're simply going to draw a graph around the asymptotes. And that's the
Mhm.
first part of cosecant x. We're done with that quadrant.
And then it's the same. I think I get the rest is the
Yeah,
same.
yeah, it's the same thing. It's going to look like like this here, and it's going to look like this here.
Yeah, I get that one.
Yeah, and then sine cosine x is the exact same method. You do the same thing.
Okay, so it's the same graph.
It's the same. No, cosine graph is a little bit different. It's kind of the same graph. It's gonna start here. The cosine starts like here.
Yeah, same graph. It's just like
It's just a shift. It's just a shift on the 90 degrees to the left. It's gonna look like this in the green. The thing in green.
okay.
Cotangent of graph is super annoying. I don't think they're gonna ask you that, but if they do, look at this. Tan has what does tan have an asymptote? Tan is equals to sine x over cos x. Yeah.
Mhm.
So whenever the y value of cos is a 0, right?
Yeah.
You get an asymptote. So when is the y value of cos x 0?
I forget to.
Use the unit circle. Where's the x value 0 on the unit circle? Oh, the
X value
coordinates
is 0 at pi over 2,
at pi over 2. What else?
and 3 pi over 2.
3 pi over 2. There we go. So that means at pi over 2, there's an asymptote because that will give you a 0 in the denominator for tan. Yeah.
Yeah.
Same thing here. It's going to give you a 0 on the asymptote. So tan x kind of looks like a cubic function, but it has multiple parts to it, right? So 90 to 270, it's 180. So that means there's going to be an asymptote at negative pi over 2 as well.
Mhm.
So this is what tan looks like. It looks like a cubic function. Okay?
Yeah.
How do you draw cotan?
You're just gonna like you flip it, but I don't know why like the zeros on the undefined or is it on the asymptote.
Give me a sec.
Yeah.
All right, I'm back. So this is the graph for y equals tan of x, yeah?
Yep.
So now we're trying to graph y equals to cotan of x, right? We're going to use the same approach that we did before. Whenever, and again, cotan of x is 1 over tan of x. Yeah? So whenever tan is 0, you get an asymptote. So at exactly 0, you're going to get an asymptote for cotangent of x. At exactly whatever this is, I think it's pi. Yeah, it's exactly pi. You're going to get an asymptote for cotangent of x. Okay?
Okay.
And now we're going to use the same rule that we used before. Let's say this is 10, yeah? What's 1 over 10? Let's say this is 10.
0.1.
0 point. See, that point is going to come all the way here. Let's say this is 5. What's 1 over 5?
0.2.
This is going to be a little bit higher than this. And exactly this is 1, yeah? 1
Same
over
view.
1 is, yeah, exactly 1 over, and then we can use the same idea. This is 0.5. What's 1 over 0.5? A2. That point is going to go up there. What's 1 over 0.1? 10. So
Oh,
there
and
we
then
go.
it keeps
It's just, yeah, it's just a
okay.
reflection on the y-axis. There you go.
Okay.
That's the cotangent there.
Let me take a pic and yeah. And yo, before you go, do you use a iPad? Like a
I
Apple
don't,
iPad or what do
no,
you use?
I don't use an Apple iPad. I use like a writing tablet.
Writing tablet? 'Cause, bro, I've been thinking of like changing from like paper to like online, but I don't even know.
Yeah, no one cares an iPad. That's like $400, bro. No one cares about that.
Wait,
You
bro,
get
it's
any of
hella
these.
expensive. That's what I'm saying.
Get any of these. Like this one is exactly the one that I have.
Sure. What's
And
this?
it's like $65 with a $15 coupon. You can even get a used one.
Bro, and like, does it save your work? Like, how does it work?
Yeah, it does. Like if it depends on the software that you use. Like this one does. If I want to save it, right? So what day is it today? So let's see if it saved anything on our session. Well, I didn't save it, but see, it remembers the last thing that we did. But you can actually like add page and like save it.
Yo,
But
if you
this,
forget to save it, you're done. Maybe.
no, you can turn on autosave. But you can use something like Microsoft Notes. That one
Microsoft.
autosaves. Yeah, Notes autosaves.
So that thing that
OneNote,
you're buying is
OneNote.
just for the iPad, and then like you can download stuff on it.
Yeah. No, this you download on your computer. That you just use to write on the tablet itself. Like this one, it autosaves. You don't even have to worry about it. Like you can close it and it's gonna be there tomorrow.
But like, yo, I suck at writing with my mouse.
No, why are you writing with your mouse? You're gonna write with this pen on this tablet.
Well, that's if I get that tablet.
Oh yeah. Like otherwise, yeah, don't worry. Don't mouse. You can write with it. Yeah. No, there's
Yeah,
cheaper ones too. I'm sure like there's like $30 ones. You see, this one's 25, but this one's gonna be not very good. You want to get at least a decent size one because otherwise it's gonna get too crammed up. Yeah, this one's
yeah,
like $43 or whatever.
yeah. I actually might have to invest in that because paper it's getting like hard to like keep up with all that.
You can always return it. You know, Amazon, you can return it within like a month, 2 months if you don't like it.
Yeah. Bro, I think I'll look into it, but yeah, I appreciate you.
All right, no worries. I'll see you next time. Yeah.
Yeah, see you.
All right, bye.